Hello there, welcome fellow explorers. Today I am going to dive into space and try to explore stars and how do scientists measure their age and how they figure out how long a star's gonna last. So, at first, what is a star and how are they born? In simple terms, a star can be called as a spheroid of plasma which is luminous and it is held by its own gravity. Stars are born in vast clouds of gas and dust, which is known as nebula. Nebula, which is called star nursery. Stars begin their lives in dense regions of nebula where gas, mainly hydrogen, and dust are abundant. Their gravitational force pulls this matter together and then gravitational collapse happens. As the gas clumps together, its gravity increases, pulling in more material, and the cloud shrinks and become more denser, causing the temperature to rise. After that, protostar formation starts to happen. At this stage, the collapsing gas forms a hot, dense called a protostar. The protostar continues to accumulate mass from surrounding cloud which emits heat but not yet visible light as nuclear fission hasn't started yet. Once the core temperature reaches around 10 million degrees Celsius, nuclear fission begins to start, where hydrogen atoms combine to form helium, releasing massive amounts of energy, and this is when the protostar officially becomes a star. After becoming star, the nuclear fusion stabilizes and the star enters the main sequence phase, where it will spend the majority of its life converting hydrogen to helium and emitting light and heat. The Sun is currently in this phase. Now, when scientists want to measure a star's age, they first look at its mass, because the more mass the star has, the more it will burn and quicker it will die. We can look at this kind of relation from this equation below, where T is proportional to 1 by m to the power 2.5. The more mass, the more burn and the lifespan decreases. Another way to measure is by HR diagram or Hertzsprung-Russell diagram. In this technique, scientists look at the colors of light stars emits from their core or the surface. When we look up at the dark sky, we can see many small dots where we can see colors like yellow or yellowish or bluish or red. When the light from the star is red, it means it's in stable form, and when it's blue, it means it's in unstable or it will quickly die. We can talk more explanatory in this here. For example, blue stars, and these are the hot stars with temperature exceeding 10,000 Kelvin, and blue stars are young, massive, and burn their fuel quickly, which means they have relatively short lifespan for about a few million years. On the other hand, white or yellow stars are the like our sun are cooler than blue stars with temperature around 5000 to 7000 Kelvin. They live longer, for example, billions of years because they burn their fuel more slowly. And there is red star. These are the coolest stars with temperature below 4000 Kelvin, and red dwarf stars can live for trillions of years because they burn their fuel extremely slow. For main sequence stars, astronomers estimate a star's age by comparing its mass, temperature, color, and luminosity to theoretical models of stellar evolution. Aside from those, scientists also uses nuclear fission rate, stellar evolution model, nuclear synthesis models to determine a star's age. And research are still going on for more reliable info, and we hope that scientists soon will post some reliable info for us. Okay, that's it for today. Hope it was informative and thanks you for watching.